Hi, my name is Justin Fleming from JTech, and today I'm going to show you how a torque converter works and the parts of it and how it's all put together. So right here, we actually have the torque converter split. It doesn't come apart like this. They just have it for showing purposes. And right here is the turbine, and there's also the piston for when the lock-in clutch, as you can see the clutch right there on the outside. And then right here we have the impeller, and then the sprag and the stator. So how a torque converter works is that over here on this automatic transmission that this actual torque converter goes to, there is the splines and where the fluid comes out. So the fluid for the torque converter comes out here, and for when the transmission actually engages the lockup clutch, the fluid comes out here. So how it does this is, say this is a torque converter, we have the turbine, impeller, and the sprag and stator in the middle. So what it does is it flows through in a vortex flow until up to the top of stall speed, and different torque converters have different stall speeds. Now what it does is, so right here, this the sprag and stator, it locks on to the splines on the input shaft of the transmission, and the actual input shaft that moves is turned by the turbine. As you can see, the splines inside there. Now on here, it only goes one way, and it locks the other. And as when it does that, it forces the fluid to push this a certain way. Now what it does is it'll come through here, it'll come through the bottom, and then come out the top, push off the stator and the sprag, and then it goes down in here and comes out here, and then goes through stator sprag again, and goes through, and then goes down through here and comes out here, and it just goes in a cycle. And like I said, it's a vortex flow, and it flows like that throughout the whole thing. Now, as I said, different ones have different stall speeds. Now, once you get above stall speed, it goes to coupling phase. And at coupling phase, this is for higher speeds, and at this point, it get the turbine and impeller, they get to at about 95% of going to the same speed. And at this point, the fluid's no longer going through the middle like the vortex flow. Now it's at rotary flow, and the centrifugal force of the torque converter is spinning so fast, it pushes all the fluid to the outside. And at that point, the sprag and stator is no longer spinning with the turbine and impeller, and it's just sitting there. It's no longer need to be locked up. Now, when you get to the end of coupling phase, the transmission and the computer is gonna send a signal to let it know to shoot the fluid to the piston here that pushes this piston out for the lockup clutch that locks up the turbine and impeller. And at this point, the gear ratio is at a 1-to-1, and this is for higher speeds and lower loads. And at this point, it's still going with the rotary flow around the outside of the torque converter, and not through like the vortex flow, which is also a spiral flow. Now, whenever we put this together, the impeller, comes off, and it goes on in here, and it has this little metal piece like this that hooks on to the actual pump that pumps the fluid out. And and lets the fluid come out through the torque converter. Now, that hooks it there, and this on that side where the turbine is of the torque converter, this bolts on to the flex plate. Now it's kind of weird how it's kind of backwards, because the turbine that's towards the engine runs the transmission, and the impeller that's on the transmission itself is turned by the engine. Now this goes on here to help with the pump, which is turned by the engine. Then you have the sprag and stator that go on there. Then the turbine and the piston go on top of that, and this is all together. It's not going to cut like this. It's not going to come apart like this. And like I said, comes up to stall speed, and the different torque converters have different speeds, and it goes in a coupling phase. And after coupling phase, it can go into lockup phase, and sometimes it doesn't do that. Just like, for example, when the trucks have like the tow buttons, you can, when you turn that on, what you're doing is turning the signal off for the computer transmission to actually lock it up. So you're not going at these high speeds in a 1-to-1 ratio when you still need torque multiplication to get that good torque to get the truck moving and pulling the load. And that is how you work and describe a torque converter. Thank you.